I am not well since a week, man. Viral fever. That's why I couldn't join.
Okay. So
Yeah.
I hope, Nikhil, that you are going to recordings whenever you're getting time.
Yeah. I'm going through. Yes. Right.
So please be, feel free whenever you want to connect with me separately for questions or issues.
Sure.
Okay. Then we are going to finish this DynamoDB today because yesterday also I had to skip this.
I have one question, Jalal. So
Mhm.
told me to practice that. So I tried. I went through the recording and I started doing the activity one by one.
Yes.
I was still facing the issue. I assigned a new role. I created a new role and given three policies. And by default, Lambda execution role policy will get created by default only.
Mm-hmm.
Tried that, but still I was facing that issue. And
We connect separately then. Just share the screen, then we will see that. Because
oh,
like this, it will be a bit tough if I try to do it. Okay.
oh,
Okay, so in last class, we had seen DynamoDB, introduction of NoSQL databases, like what it is supposed to do, its use cases we had seen. We seen the difference between scan versus query, like how the scan works and how the query works. We had seen those differences. And then we see in the secondary indexing that how we can utilize the secondary indexing in our DynamoDB tables to optimize the query performance and to reduce the cost also. Okay, so we have seen the two kind of secondary indexes. That is, first is local secondary index, and then we had seen this global secondary index. Then we had also seen now we have to see the consistency modes. Okay, so as we know, if I go inside my DynamoDB tables, okay, let's say this is the one we have created last time, and if I go inside the global tables, if I say create replica, I'm able to create my replica into another region. Okay, let's say I create this into Sydney. I will be able to do that if I just click on the create replica. Just keep in mind that this is going to be a double charge for your DynamoDB tables. But in this case, let's say we have one DynamoDB table is standing in Mumbai. The current one is in Mumbai, and the other one we are trying to create in Asia Pacific Sydney region. Okay. So now, and it's going to obviously it's going to perform replications. So sometimes it might happen that some record that we had written in Mumbai region, and if at same time if we try to read that in a Sydney DynamoDB table, we might get stale data. Okay, stale data means we might see older records. So this means, let's say I deducted some amount of rupees from my ATM machines, and exactly at the same time, or maybe not at exactly the point at the same time, maybe a 1 millisecond delay, some milliseconds delay is there, and I try to read the same account balance from the Sydney's replica, then I will see the previous balance. Okay, and this problem is called this. This problem is called actually consistency issues. That means your data is not consistent all over your replicas. So that whatever we have created in DynamoDBs, our replicas are not inconsistent with each other. Like some replicas are a bit ahead and some replicas are seeing the stale data. Okay, so then there are two consistency mode available in DynamoDB. One is eventually consistent. That means whenever we write data into some DynamoDB tables replica, it will take some time. Okay, now that means it will take a few seconds. Not, I mean, it actually does not take seconds in practical. It's just a milliseconds game. But when we might see some stale data into another replicas that we have in our DynamoDB cluster. Okay, but if we want if it is a very bit a critical issue for our project, and if we want 100% accurate data on all our replicas, in that case, we should go ahead and choose strong, consistent mode for our tables. OK, this means whenever we are going to read the data from any of the replicas or any of the DynamoDB instance that we have in our application, we are only going to see the latest records that is available at the moment in all the replicas. All the replicas are going to be in completely sync. OK. But if you're having some global secondary indexes, that means global secondary indexes are still going to be eventually consistent. This means if you're reading from global secondary indexes, you might still see stale data, and strong consistent reads are twice expensive as eventual consistent reads. This means if for some if you go inside this, OK, instead of create replica, if I just come on tables and try to create a table, then let's say some name I gave it here. OK, then if you choose this setting of customize here, and if you choose the capacity calculator here, OK, and see for reading 10 KB of information, OK, in per second, let's say 10 KB of data size, and I want to read 10 such data size in 1 second. I am getting that I will be needing 15 read capacity units for this table, and I will be charged around $7.16 per month. But if I make it from eventual consistent to strongly consistent, then if you see capacity just goes double, and my charge is also bit increased. OK, so we should take care of this part also, that if we are going to use strong consistent mode of reading, then we have to pay a bit extra. So only if it is very much required, then we should go for a strong consistent mode. Anyhow, eventual consistent mode is also very good. You don't see any delays such as like it's going to take minutes or hours. It's not like that. Max some milliseconds delay might be there, or max 1 or 2 seconds delays you can expect. So yes, if you have any questions about consistency modes.
I have one question. This Dynamo
Yes, please.
Redshift only. It has a separate cluster. We can create a separate cluster also, and we can use a serverless architecture also for.
No, it's not cluster. See, you are creating replicas in another region. You are not launching a cluster here. DynamoDB is a kind of serverless architecture. It just works it just works on the how much capacity you have provisioned. OK, and you can create replicas. Now, use of replicas is that I wanted to discuss in the global tables only. But see, use of replicas is, let's say you are a worldwide application such as Flipkart or Amazon. And in that case, if you just launch one DynamoDB table in India, and then you are having some customers in US also, then those guys are going to get some lag. See, whenever we see these are whatever we are creating on cloud, this is actual resources are getting deployed in some physical location. And when you select region, that is a physical location. So all the resources are getting deployed. Like if I are launching a DynamoDB table in Mumbai, and I'm trying to access that DynamoDB table from US region, obviously I'm going to get some lags there. OK, and obviously no good business wants lags in their online applications nowadays. So that's why you can use the function called global tables. OK, with the help of global tables, you can create replicas of your table in any region that you want to choose. Now, the more number of replicas, the more charge we have to pay. And these replicas have two types of consistency modes. One is eventually consistent, that is, and then we have strong consistent. Difference you already know. With eventually consistent, we might see some stale data in one of the replicas. With strong consistent mode, you will never see any stale data.
DynamoDB, it's a kind of database only.
Yes.
So it must be having its own storage.
Yes, it is having its own storage. Yes, correct.
Okay. And we can provision this also, and we can use as a serverless also, this DynamoDB.
No, we are not provisioning it. See, storage is like if you see in the create table part, I am just deciding the speed of read and write. I am not deciding the speed of storage. Sorry, I'm not deciding the size of storage. I'm just deciding the speed of my read and write. Okay, that how much compute you need. Basically, we are defining that part. Storage is like if you store, it's like S3. You store the data and it's going to increase its sizes. There's no
I'm
never.
just I'm just comparing with Redshift. We are loading the data, and we can use the S3 bucket data also. In case of DynamoDB, since it's a dynamic schema, so the same we are using everything is same, but the how the data is getting stored is a different one.
Not everything is same. It's just the database, a Redshift data warehouse. First of all, it's a very huge difference. Okay, do not compare this with Redshift. Use cases are completely different. Redshift is made for the analytical processing. DynamoDB is something that you should use for transitional processing, where every second you are writing, reading, or updating some records in those cases. Now we should actually compare this with the SQL databases. Okay, if you have if some competition is there, it is coming from the SQL databases. If you just compare this MySQL or Oracle part of side, then the difference between DynamoDB and Oracle is with DynamoDB you can have varying schema. That is not possible with your SQL database. But with SQL database you can write joins, group bys, and queries. Those queries like with having groups and joins that you cannot achieve with DynamoDB because schema is like for obvious reason schema is varying. DynamoDB is supposed for heavy reads, heavy writes operation. Okay, such as again I'm referring the gaming examples. Let's say with these very famous games like Dota and some what we have this PUBG and all those games. Every second, some players are playing the huge games. They have to read some data. They have to write some data. For such use cases, you can say DynamoDB tables are built, and every user might have different columns, different players, different names, different character they might pick from the game, different weapons, different features they might pick from the game. So that's why we might have varying schema. And now that those records are actually not a very important records. Okay, those are a lot of banking transaction, credit card transaction, or very useful information. So maybe you want to delete that information after some time. So for those use cases, you want to use DynamoDB table.
Okay. And I have used SQL so far with row and columnar storage, but since DynamoDB is a dynamic schema, so how this table creation will also change over the time, or like how it is?
There's no create table command now. You can just simply define a table here on the screen. Like I'm doing, I will define my table name. I will define the partition key and short key. If I want to apply some indexing, I will do that. Then you can add any columns, remove any columns, upload any columns like that. So we are not defining a schema first, then loading data. We are just defining the partition key and short key, then loading data. Whatever columns we have in every row, those will get saved in the JSON documents. So basically, we are just saving some JSON documents here in the key value format. Those gets a partition key assigned, and that is a primary ID for your row. If you see these tables here that we have, leave. Let's say this is my table. Okay, this table I have defined, and then I'm just writing my records here. If I just click on export table items, okay, then this is my record. Every record is just if you just click on JSON view, that is the original raw data. It's just a JSON file that we are storing behind the scene. These all columns can change in every row. This is one row only. Okay, this is one row only. If you see this in form format, this is something like this you are going to see. See, all these databases, data warehouses, and NoSQL databases have different use cases. You cannot replace them. Like you cannot replace your SQL server with DynamoDB. You cannot replace your SQL server with data warehousing. SQL servers or SQL was there, is there, and chances are it will be there in future also. Okay, these all databases, NoSQL data warehouses are the use case specific or improvement you can say over the sequels. Okay, is it clear, Osha, to you?
Yeah, yeah.
Okay, then we will move ahead. Table classes actually we have already discussed in previous lecture. It is something like S3 only. If we want to frequently access our data in read and write format, then we are going to store the data on standard table only, the normal one. But just in case if we have a DynamoDB table that where we are just writing the data and we are not reading it very frequently, in those cases, we might want to store our data on infrequent access. That means we are going to pay a bit less charges for our storage side. And as we are not fetching it on daily basis, we are going to pay bit less. This is I mean, this table class is available, but most of the times you might use a standard table only. Something like S3 feature only, the storage cost will reduce down if you are not accessing the data very much frequently. Okay. Then we have already discussed about the topic of global tables. Okay. This is something as I mentioned that if you have a global application, you want a database that is globally available nearest to your consumer base. Okay. And you don't want to have any lags or issues or delays in your responses, then maybe you want to create replicas of using global tables, and they will be available for multi-writes and multi-reads. That means, I mean, it's not like it's simply a read replica. It is going to be multiple engines running at the same time, and you can write in any database and read from any engines. It's something like that. So this basically helps you to launch your DynamoDB tables in multiple regions at the same time. So if you just see here, if we just go inside the tables, then we have global tables, and as you can see, we can create replicas. Okay, if I hit on create replica, you can choose the target region, and this is not simply a read replica. Okay, it's just not like that you can only read from this replica. It's going to be write and read, both actions you can do on your replicas also. So there is a concept of read replicas in some databases that allows only you to, like, one primary engine will be there to write the records and other replicas will be there to just read only format. But this global tables are read and write both. And then we have something known as DynamoDB DAX clusters. Okay. So when we have some databases also, okay, whether it's a database or data warehouses or this thing, we have some very frequently running queries. Okay. We have some very frequent running queries. Those we run multiple times in a day or multiple times in some time span, and that gets you same type of data stored or fetched from your databases. So if you have such kind of application or use case, we can go ahead and launch DynamoDB DAX clusters. So DAX clusters are nothing but a caching feature, you can say, on DynamoDB. So it's like if you are running a query multiple times, instead of fetching the record from the database, okay, instead of fetching the records from the database, it's just going to hit the cache first, and if the results are already there in the cache, it's going to return the results from the cache memory only. It's not going to perform the read query from the database or the table that you are having on the DynamoDB. Okay. this is your DAX clusters. Use cases of DAX are if you just imagine, whenever we have a very frequently running query that we want to run every time, or you can say most of the time in a day. So if I give you a very layman example of this, so sometimes we load a website and it might take a minute or two to load that website. But if I load the same page again, then it loads very much faster than the previous one. So that is an example of caching. What happens? We get the cache stored in our local machines. And instead of serving the request from the server itself, we just get the data loaded from our machines or the cache memory that we have built. So it is the same feature. Just in case if you want to use, you can go ahead and use this. Okay, and this DAX actually with the DAX involvement, you no need to create any no need to create or manage your caching algorithms separately. It can handle your caching algorithms. It can expire the cache data also. Expire means, let's say today I have read some data from DynamoDB and that got stored in cache, and next time when I read that same data, I get the data loaded very faster, and I do it for complete day and I get data loaded very much faster. But what if the data has been changed on your actual database? Okay, in that case also we need to expire the cache also. Okay, so all those algorithms of expiring the cache, checking the cache, storing the cache, or managing the cache is completely managed by the DynamoDB DAX clusters. Okay, so expiring the cache we also called sometimes cache invalidation. That means the cache that we have built right now, it's in an invalid state and looks like we need to refresh this from the database. So this is your DynamoDB DAX cluster. Actually, I don't have any website or something to show you this practically. So unfortunately, I'm sorry on this. And anyhow, as a data engineer, chances are very rare that we will launch an DAX cluster, because this is mostly to help and increase the query performance on the web and front end side only. So if it's something, if you have questions theoretically, you can ask me. Otherwise, we are going to move ahead from here.
DynamoDB we are using. Only we are creating the table, right?
Yeah, table we are creating, but DAX cluster we are not creating.
Cluster part admin will take care, but from the data engineering perspective, we are creating tables and all.
See, understand this thing. You need DAX clusters or caching algorithm when your query is serving something very often. Okay, so how do I explain you this? Let's say you want to see the cricket score results. Okay, and you're storing it into some database. Okay, now every second millions of users are actually accessing that. So instead of allowing all those million users to hit your database every time, whenever the first user or second user just checked into that score, you store that into your cache engine. Okay, that is our in-memory cache engines, very faster. And next time when somebody asks the same score in the same second, you respond to that from cache. I mean, not manually we are going to check that process. It's a coding that we do behind the scenes. So you are going to serve them from the cache. So now this kind of use cases are built in front-end applications only. And whenever you see some updates are done in the score, you also need to invalidate that. So obviously those things you have to code, okay, and that is mostly served for the front-end applications, where the front-end application is accessing your back-end data very frequently.
This part I understood.
Okay.
From the data engineering perspective, from the DynamoDB portion, what will be my responsibility other than creating a table?
Your responsibility might not be nothing, because sometimes you just don't use DynamoDB. Like it's not necessary that every project will fit in DynamoDB in their data pipelines. It's not like that also. OK. And if you talk about use cases or the work that you can do on DynamoDB, maybe you can maybe you are writing some queries, maybe you are loading some data, maybe you are unloading some data, maybe you are connecting DynamoDB to your analytical tools and reading from there. OK. So day-to-day tasks on DynamoDB might not be as that much, but you might be using it in your project. OK. Let's say if something goes wrong in DynamoDB, then you might have to check and look into that what is the issue here. Am I getting some stale data? And then it's a consistent remote that you need to fix. You might have to create a secondary indexes. So you should know conceptually, but yeah, day to day, nothing like from last 2 years, I have not done any task on DynamoDB. We are using DynamoDB for our job updates. OK. Sometimes I just go on DynamoDB and check the status of my job, just reading the data process. OK. But I'm not doing any development or changes on DynamoDB. So not every tool is changing every day.
Okay.
Oh. OK. Then we have a very unique feature in DynamoDB called as DynamoDB streams. OK. This DynamoDB streams is a time ordered sequence of item label modifications in DynamoDB table and stores information in a log of 24 hours. OK. So this is, if I say in the easy language, is a change data capture. So let's say today you have loaded some 1,000 records or any amount of record that you can think. OK, we are in the DynamoDB. Now those records are getting updated or modified every day basis, and you want to see which records are getting modified every day. OK, you just want to see what are the records that are getting updated in my table on daily basis. So for that, you can create DynamoDB streams. So whenever I change some data into my DynamoDB, it is going to generate an event like the event we have seen in the S3 and Lambda. Same way, we can have this events built in our DynamoDB tables also using the DynamoDB streams. So whenever I make a deletion of record, updation of record, or addition of record, my table is going to trigger a Lambda function. OK, it can actually also trigger the kinesis part, but I mean, two options we have, Lambda and kinesis, and then we can store those results at some other storage or some analytical layer. So let's see this practically. So let's say I have this table called demo DynamoDB. Okay, or I mean, I'm just going to take this demo DynamoDB is fine actually. And then if I go inside this option of exports and streams, OK, then if I just slightly come down, and if you see my this DynamoDB table is actually streaming my records, like it is on right now, it is on. OK, let me actually turn it off. Then I will show you how to turn it on. OK, so this is what we get. OK, so if I click on turn on, it will ask me. OK, let me actually go back. Exports and streams. I want to turn on DynamoDB stream details, not the kinesis stream right now. If I click on turn on, then it will ask me that what you want to capture. You only want to capture the key attributes. So let's say I have 20 attributes in my table and I only want to check which keys got modified. That means which partition key and short key got modified. I don't want to capture all the attributes of my table. In that case, you can say key attribute. OK, Then you, or let's say a new image, old image, and new and old image means if some record has been updated, or in that case you will only see the new image of that. That means what is the latest value of that, only that portion you will get to see. If you select old image, what was the status of that particular row that has got modified, only that part you will see. And if you select new and old images both, then we are going to see the both differences, like you are going to see previous version also and you are going to see new version also with all the attributes available. So I'm just going to select this part, new and old images, and I am going to click on turn on stream. This means I want to check my also and old image also, so I can make the comparison. I'm just going to click on turn on stream. Okay, once my stream is turned on, as you can see my stream is turned on. Now what to do after this? Let's say my stream is turned on. Okay, but what action do I need to take on this? Okay, whenever some updates is happening in this table, what action I want to take? So for that I can create a trigger. I'm just going to create a trigger, and I need to choose my lambda function for this. So I am going to choose, there's a function called DynamoDB stream capture. This I have built. I am going to show you the code also, don't worry. This I am going to choose, and this I am going to trigger at the one record only, because we are not going to modify too many records. This means if I say 10 records, so only in the case my 10 records has been modified, in that case my lambda function will start running. Okay, at a single time it's going to take 10 records, but we are saying one record only, and we are keeping the trigger turned on. Okay, so I'm going to trigger my DynamoDB stream capture lambda function. I'm just going to hit on create trigger. It's actually a very simple lambda function. Then let's see that what's happening there. So we can see this is actually getting triggered from DynamoDB. Okay, like earlier we have seen S3 here, but this time we are triggering it from the DynamoDB. And this is my very simple lambda function. Actually, I'm not taking any action right now. I am just printing my messages here. Okay, I am saying print what is the event ID, what is the event name, and then print the DynamoDB record that we have modified or changed. Okay, I'm just going to comment this part for now, or actually let it uncommented. Okay, no, nothing is actually harming this. So this is actually turned on. My stream is turned on. My lambda function is configured. So if I come back here in this DynamoDB table, demo DynamoDB, if I go in the export items, so let's say I modified this user ID and its Gmail is Y. So let's say I say changed here. Okay, and I click on save changes. Now if I come inside this function, if I go inside the my monitoring part and go inside view CloudWatch logs, now let's make a few more changes. I ideally should have got it there only. Need to check why it is not triggering. You should have got it triggered by now. Okay, so if I just again check this out, my DynamoDB table. Okay, if I go on view table details, exports and streams, my stream is turned on and state is disabled actually. Okay, let me modify this. I need to edit this thing, configure why its state is disabled. Let's remove the trigger from all these things. Delete. Then this is the one. If I just click on this and edit, and then if I come here, additional settings, activate trigger, save this. Okay, now it is enabled. Okay, it is enabled on DynamoDB table. If I refresh this, it is enabled also. Now if I make any changes into my DynamoDB table, let's say I modify this to my full name and click it on save change. Let's say I modify this record from Gmail to Hotmail. This is my column name. Okay, just do not get confused here. I'm changing it to Hotmail, and if I just come back here now, refresh this, I can see my stream has given me output, and I am able to get it on 21:43 of 30th May. Now, if you see this thing, my stream is capturing all the changes here. OK, so it says event is type of modified. OK, if I just let me just take this column into let's just get it JSON lint. Out on Notepad. You can see this is my event ID and my details are here. Like this is my new image and this is my old image, and I have modified my Gmail to changed. OK, this is the previous record it has captured. And likewise, if you see, there's a change on user ID 3, and I have modified a modified record is here. New image is Hotmail, the one that I have changed in the Gmail column. OK, and like that, I will like, and my old image was changed here instead of Hotmail. OK, like this, I can get track of my changes on my table using DynamoDB streams with the Lambda functions. So now, if you have any questions, please let me know.
Could you please show the steps again? How did you connect this Lambda trigger with this?
Let me actually remove all these things. So you have to go on your Dynamo. Let's actually start from here. You have to go on your tables, choose the table that you want to modify. Let's say I choose this Dynamo. Let's say I choose this table. OK, you have to go on exports and streams. Here, if you turn on the Kinesis data streams, it's going to start writing on the Kinesis. If you turn on this DynamoDB streams, then it's going to start asking you for a Lambda function, and then you can write the records on Lambda function. So just say turn on here. I have choose new and old image. That means I'm also interested in both the previous image and the old image. Click on turn on stream. OK, then if I click on this turn on stream, it will ask me for it to set up a trigger. I can create a trigger here. I can choose my Lambda function. So first of all, I have to create my Lambda function. Then that I can choose here. OK, so I will just come on here and just choose DynamoDB stream capture and choose the batch size. That means how many records you want to process at once, at least. Okay, so I'm choosing 1 because I wanted to show you practically. That's why I choose 1. Maybe you can choose 100 and 1000 like that. If you choose 1000, then there should be 1000 changes made in your DynamoDB table before you can see any result on your CloudWatch logs. Then once you've chosen the DynamoDB, Lambda function, and then once you have chosen the batch size, you can click on turn on trigger and click on create trigger. Just make sure your trigger is in enable state. Okay, once it is in enable state, just go here, click on explore table items. Let's say I create an item here because we have no item here created. I create a item here, let's say 1. Date I give 30/05/2023, and I might add one more record. New value test stream. Okay, and I will call it tested. That means I simply created a column named as test stream, and I'm saying tested. This is my different table. I am going to create this item. I will come back to my CloudWatch logs. I am going to refresh this, and in few seconds I will see results here. Okay, if the state is enabled. Actually, you can see it is, I have already got that here. My test stream with tested, and it's just have new image because obviously we created new record. That's why we're going to have the new image only. No old image for this one. So this is how we can actually stream the records. Okay, now I have an assignment for you. If you just come and look inside this code, if you check this thing first, so we have, let me actually get it completely. It is old image 025. It is this one. I need to take it from Gmail. Actually, this is actually my complete record. What I want you to do, I want you to write this into a CSV file, only the required information. So I want you to write, let's say what we want to write, is in DynamoDB, and do I have okay, so I wanted to create a table where you have your event ID, your old image, your new image, timestamp. Okay, and yeah, I mean that these 4 columns are fine. So output something, it should be like event ID is this one. Then I'm going to put a comma. Okay, new image, you want to have something like this, date. All the columns name, like whatever date is there. Then some separator, maybe a pipe. Then you want to have Gmail, pipe, then user ID. Like whatever the columns that you have inside this new image, all the columns you want to I want to capture in a pipe separated format. Then all the captures that we have in the old image, I want to capture those in a pipe separated format. And whatever the timestamp is there, okay, whenever this record got changed, okay, I want to get the timestamp here. Or let's say the timestamp will be approximate something will be like this 30/05 2023 91:52 and some seconds. So I want to modify this dictionary into this format. So you can take your time, try it out. If you cannot, then obviously at the end of this course, I'm saying end of this course because in between we are going to start with a Lambda mini project. In that I have same kind of example where we are converting a complex dictionary response into a CSV file. Okay, so maybe you can take a hint from that. So right now, if you solve it before that mini project, right now it will be like you solve a very hard problem, and if you solve it after the mini project, then it's still you are doing good. And if you solve it after when I provide it to you, and if you get it, then still we are okay because this problem that I have given to you, it's not an easy one. Okay, it will need some skills, some Python coding to break it down. So yes, if you have any questions about this, and if I just give you hints, we have seen how to loop around a dictionary. This is a dictionary column, and it is also stored in the format of dictionary. You can use a for loop here to get all these details. Same way you can use for loop on this column to get these details. And after every column, you have to just append a pipe there. Okay. So this is how we have to work. Just try it out. If you can, it's all good. If you can't, then no worries. We tried. Any questions? Let me know.
Can you paste this?
Maybe you can take the screenshot, or I will actually because if I paste this in text or chat box, it will actually lose its format.
This then again I have to type everything.
No need to type, na? Just create a function, connect with that, and you will get all these details. No need to type. And anyhow, you code you have to type. Where it is gone. If I just come here in the chat box. Okay, a bit strange. Snipping tool. That's all.
If you can save this notepad and share, that is also.
Actually, but why I was not able to Dynamo. No, D drive or maybe desktop. Okay, then this, and this desktop. This is you want. And use IAM role basic lambda execution as 3 full access and DynamoDB full access. And one more thing I will suggest you create this dictionary on your instead of using lambda function, you can also try it out with your what we say it's a better notebook. So something like this you can try. Open your Anaconda tool and go on Jupyter notebook, Jupyter notebook. Okay, so the one that I have here, untitled 6. So if you check out this thing, let's see, I have got that event created here. Okay, now I am actually applying all of my changes. So if you can get it like this, it's all good. Otherwise, anyhow, you can try it on Lambda functions also. Running Lambda function is not a very costly operation. and anyhow you should be within the limits of free tier. So you won't get any charged on Lambda functions also. But yeah, anyway you prefer, you can try it out. Okay, so this is what it is. You have an assignment with you, and DynamoDB is actually done. It's just a database with some different features than other SQL database. And something, if you have, you can ask me some questions, some doubts or issues. Otherwise, we are going to start with a Kinesis part from tomorrow. We are going to see how to process live data. Any questions? So who all we have? We have Varsha, Nikhil, and Rama.
Question that for that I need to share a screen. Other than that, I'm good.
Okay, just stay back for 2 minutes. Rama and Nikhil. Okay then, guys. Thank you. Varsha, maybe you can share the screen.